Q2C target drone, ground-launched from a zero-length rail. It is also air-launched from a GC-130 aircraft. It has performed reliably at altitudes up to 59,800 feet. Developed for the U.S. Air Force by the Ryan Aeronautical Company, this drone is by all three branches of the Department of Defense. The mission of the Q2C is to furnish economical, high-speed target service. Because of its small size, it is necessary to augment or increase its radar reflectivity to simulate a normal-sized manned aircraft against which our missile systems were designed to operate. In August 1960, the Air Force awarded a contract to Ryan for feasibility and systems integration studies, scale model radar reflectivity tests, and the flight demonstration program on Q2C drones. Radiation Incorporated, under subcontract, conducted scale model tests. These tests indicated that the effective radar echo area of the Q2C drone could be reduced significantly by the installation of a screen across the engine air inlet and by blanketing the sides of the fuselage with a radar energy absorbing material. Systems integration studies conducted jointly by Ryan and Hycon Manufacturing Company indicated the feasibility of installing a high-resolution photographic sensor in a modified Q2C drone aircraft. Flight tests conducted at Holloman Air Force Base correlated with scale model tests. Conclusions evident from this project indicated the feasibility of conducting photographic reconnaissance missions with a small drone aircraft. Project Firefly was the next step. This is a summary report on that project. On 5 February 1962, a contract was awarded to the Ryan Aeronautical Company. The objective was to modify the standard Q2C drone to a photographic reconnaissance configuration which had a very low vulnerability to attack. The desired criteria were range 1,200 nautical miles, cruise altitude above 45,000 feet, and photographic resolution of 2 feet from an altitude of 45,000 feet. The program was scheduled to be completed by 15 May. The engineering and modification work were accomplished at a Ryan facility in San Diego where maximum security was assured. To meet range requirements, the fuselage fuel compartment was extended to increase the capacity from 100 to 168 gallons. A Hycon H-233 camera was installed in a new, larger nose section equipped for environmental control. An MA-1 flux gate compass system and a timer programmer was installed to provide a program navigational capability. One set of Q2C ground support equipment was modified for use with Firefly. GC-130A aircraft number 496 was assigned to the project and modified so Firefly drones could be launched from the inboard pylons. Analytical and simulation studies were conducted in order to minimize flight test time and set up operational parameters. On 1 April, the first of 2 test drones was completed and airlifted to Holloman Air Force Base. On 9 April, 63 calendar days from contractual award, the first captive test flight was conducted by a joint contractor U.S. Air Force team. Flight objectives were to check the operation of the guidance system and flight programmer and to serve the dual purpose of on-the-job training for the GC-130 launch crew. The captive flight was completed successfully, and on 11 April, a pre-flight of 56 minutes was completed. Flight number 2, being a satisfactory test flight, meeting all objectives and demonstrating adequate system performance and reliability, permitted the following mission to be scheduled off the range. On 20 April, the first off-range flight was conducted. After the B-57 chase plane rendezvoused with the drone was permitted on a programmed flight up the Wendover corridor. An automatic course reversal was completed, and the drone returned to White Sands missile range after a 332 nautical mile flight. On 14 April, Firefly test drone number 2 was delivered to Holloman Air Force Base and prepared for flight. 81 days from date of contract, the first complete Firefly configuration was flown. The flight lasted 2 hours, 24 minutes. The ground track covered 1,080 nautical miles. 17 course reversals were completed. The programmer guidance system operation was satisfactory for the entire mission. Photographs were taken of numerous landmarks and a resolution target. A review of the film negative showed a very high resolution. During test flight number 5, conducted 3 May, inadvertent loss of radio carrier resulted in an off-range recovery, with the drone landing at an elevation of 8,000 feet in an unpopulated mountain area. A ground crew subsequently disassembled the drone in the field and manually loaded it onto a 6x6 truck for return to the airbase. On the 10th of May, this same drone was used to complete flight number 6. The final flight of this drone occurred on 16 May. Major damage occurred to the drone during recovery impact in an area that was experiencing high surface winds. The camera and film payload was recovered in spite of the extremely hard 30G landing. The drone is economically repairable. Flight test results indicated that the desired range could be achieved. The cruising altitude and camera resolution were exceeded. The guidance system demonstrated the capability to fly a desired track within 4% for outbound legs. The reliability of the system assured operational success. Prior to the completion of the Holloman flight test activity, a special Q-2C flight was conducted in order to test the ability of the F-106 weapon system to acquire, lock on, and fire against the de-augmented drone. Recorded results indicate that the AGC of the missile receiver was marginally adequate to fire in only 1 out of 3 attempts at a range that did not preclude missile guidance. With the completion of testing on the Firefly system at Holloman Air Force Base, further attention was turned to the consideration of vulnerability. The final flight test in support of Project Firefly was conducted at Tyndall Air Force Base, Florida. 2 Q-2C drones were prepared with the Firefly-type radar absorber blankets, and plans were made to launch them on the Tyndall range. On 17 May, the Holloman Joint Flight Test Crew deployed to Tyndall and launched a de-augmented Q-2C drone. 5 F-106 fighter interceptors, armed with GAR-3A missiles, were vectored into position by DCI. All attempts to intercept the drone deteriorated into tail chase attacks. The small radar size of the de-augmented drone precluded lock-on and firing until range was below minimum on all other attack courses. However, all 5 fighters were able to lock on and fire from a tail chase position. The firings occurred at a range of approximately 2 miles, the minimum that missile guidance can be expected at the test altitude used. Each fighter salvoed 4 missiles. 20 missiles were fired and no hits. 15 May 1962, the Firefly program was completed on time. Performance summary shows a range of 1,200 nautical miles, a cruise altitude above 50,000 feet, and a photographic resolution of 1.5 feet from 45,000 feet. Firefly has demonstrated high survivability. All requirements have been met or exceeded. This program has resulted in the on-call availability of 2 operational Firefly vehicles with adequate spare support. The joint contractor, U.S. Air Force Deployment Team, is well trained, and the systems are deployment ready on 72 hours' notice.